there is a truth few have ever considered. The space above and below our solar system is not an empty silence, but a series of cosmic undercurrents holding the scars of ancient supernovae, the glow of million-degree gas, and the quiet flow of dark matter threading through everything. We are drifting gently within a boundary no one realizes we have crossed. If this thought stirs something in you, leave a comment and tell me what you believe truly surrounds us. And now, let us move to the first sweet yet haunting question. Why does the Sun float a full 55 light-years above the galactic plane? Far above the galactic midline, where most stars gather like grains of luminous sand pressed into a cosmic shoreline, our Sun floats in a strange and solitary position, 55 light-years above the great disk of the Milky Way. The solar system drifts quietly, as if held in the soft breath of something ancient, something patient. Astronomers once imagined the Sun would sit exactly in the plane of the galaxy, moving with the crowd, obeying the geometry of stellar traffic. But instead it hovers above that bustling sheet of stars, like a lantern suspended from an invisible thread, glowing alone in a gentler corridor of space. As astrophysicist Sean Carroll once said, "The universe is under no obligation to make intuitive sense to us." And the Sun's strange location is one of those quiet reminders that the cosmos writes its own rules. This elevation is not random, nor is it permanent. The Sun is moving in a slow galactic dance, rising and falling across the Milky Way's thin disk on a cycle lasting nearly 26 million years. It is a motion so vast and unhurried that humanity has existed for only the smallest heartbeat of a single swing. And yet this oscillation touches everything that surrounds us. The galaxy pulls gently downward with the combined gravity of billions of stars and great rivers of dark matter. And the Sun responds like a weight on a cosmic spring, drifting upward, then returning downward in a rhythm older than any mountain on Earth. When we imagine the Sun's path through the galaxy, it is tempting to picture a neat circle, a tidy orbit. But reality is softer and stranger. The solar system is not simply going around the galaxy. It is weaving through it, rising and dipping like a ship carried on unseen tides. With each oscillation it passes through regions of differing density, differing radiation, differing magnetic fields. As the astrophysicist Vera Rubin once noted, we see only a sliver of what shapes us. The sliver in this case is the recognition that our place in the galaxy is not static, but rather part of a long, slow breath the Milky Way has been taking for billions of years. The question that intrigues both scientists and storytellers is simple yet profound. How did our Sun end up 55 light-years above the galactic plane? The answer lies in the combined gravitational forces from the disk and the halo, as well as chaotic influences from the early solar system's birth environment. In its youth, the Sun was likely part of a star cluster, jostled by siblings, tugged by passing clouds of gas, shaped by the swirl of matter that once crowded the Milky Way's spiral arms. Over time, those interactions nudged the Sun upward, giving it a gentle vertical drift that would later stretch into its present motion through the galaxy. This vertical displacement may seem trivial across the immensity of the Milky Way, yet it may have shaped the destiny of Earth and life itself. Because the galactic plane is crowded, bright, and dangerous. Closer to the midline lie denser clouds of gas, higher radiation environments, and more frequent supernova events. The Sun's elevated position may have spared Earth from intense bursts of cosmic rays during its early development when the fragile chemistry of life was first forming. As Carl Sagan once reflected, "We live in a universe where small differences can be everything." And perhaps this gentle separation from the galactic crowd was one of those quiet yet life-altering differences. But this safety is not permanent. The Sun is not fixed above the plane. It is drifting slowly downward in its current phase of motion. In roughly 30 million years, it will cross the galactic plane again, entering a region denser than the one it currently inhabits. Each crossing exposes the solar system to gravitational disturbances capable of nudging the distant icy bodies in the Oort cloud, that vast spherical reservoir of comets stretching almost halfway to the nearest star. When the Sun plunges through the crowded disk, tiny gravitational differences accumulate over millions of years, shaking loose, long frozen objects and sending some inward on long, dramatic journeys toward the inner planets. It is a cosmic billiard game, neither hostile nor kind. Simply a matter of gravity doing what gravity always does. Some researchers have wondered whether these periodic disturbances could be linked to patterns in Earth's geological record, particularly extinction events. The idea was controversial from the moment it was proposed. And as newer data arrived, the supposed pattern faded under scrutiny. And yet the intuition remains compelling, that in the deep past, Earth may have felt the breath of the galaxy press upon it in subtle but significant ways. As paleontologist David Raup once said in defense of bold questions, "The universe is under no obligation to be simple." And so the possibility that cosmic motion touches biological history remains an open door, waiting for better evidence to step through it. Still, even without a dramatic link to mass extinctions, the periodic crossing of the galactic plane carries undeniable consequences for the solar system's outermost frontier. The Oort cloud is held in place not just by the Sun's gravity, but by the delicate balance between solar attraction and galactic tidal forces. When we pass through denser regions of the Milky Way, that balance shifts ever so slightly, enough to alter the paths of trillions of icy bodies drifting in darkness. Henry Norris Russell famously remarked, "The universe is vast and wider than our imagination." And nowhere is that more apparent than in this slow choreography between the Sun and the galaxy. A dance measured not in lifetimes but in aeons. As we picture this long vertical journey, it becomes easy to romanticize the Sun as a wanderer, a quiet traveler crossing invisible boundaries in the darkness. But there is truth in the poetry. The Sun is moving through environments our species has never witnessed, slipping through vast regions of hot gas, magnetic fields, and dark matter streams as subtly as a feather gliding on a breeze. These transitions shape the heliosphere, the great bubble of solar wind that protects Earth from cosmic rays. When the Sun moves into denser galactic regions, the heliosphere contracts, allowing more high-energy particles to seep inward. When it enters emptier regions, the heliosphere expands, wrapping Earth in a thicker shield. It is a dynamic boundaries pulse, responding to the galaxy like a leaf responding to the river beneath it. Even the simple fact that the Sun is rising or falling carries implications for the future of astronomy. Because as it moves through the galaxy, the view of the heavens slowly changes. Stars appear to shift their relative positions over deep time, constellations reshaping themselves across intervals far longer than recorded history. We are passengers inside a slow celestial elevator, drifting upward now, though someday drifting down again toward the denser heart of the Milky Way. In contemplating all this, one lesson comes gently into focus. The solar system is not an island, and Earth is not a still point in the void. We are part of a grander motion than we can feel, a motion too slow for the senses yet too vast to ignore. The universe shapes us even when we are unaware of its touch, and perhaps that is the quiet beauty of our place in the cosmos. For me, the most humbling realization is that we inhabit a galaxy that is not static, but alive with motion and memory. Our sun is not anchored, but drifting through environments sculpted by billions of years of stellar birth and death. And each rise or fall across the galactic plane is a reminder that change is woven into the structure of everything, from galaxies to living creatures. Neil deGrasse Tyson once said, "We are part of this universe. We are in this universe. But perhaps more important than both is that the universe is in us." And indeed, when we watch the slow oscillation of the sun, it becomes clear that we carry within us the echoes of motions far older than human thought. So as we drift 55 light-years above the galactic plane, carried by the quiet breath of the Milky Way, let this truth settle gently into your mind. We are travelers in a cosmic tide, rising and falling across timescales too immense to fathom. Our home is not fixed, but sailing through the great river of our galaxy. And every oscillation is a reminder that existence itself is motion, and that life on Earth is just one delicate arrangement in a universe that is forever in flux. If you feel the wonder of this journey, let your thoughts drift in the comments below, and share what this long galactic motion makes you imagine about our future. For in asking such questions, we continue the oldest human tradition of all, lifting our eyes to the stars and whispering to the darkness, where are we going next? Far above the galactic midline, where most stars gather like grains of luminous sand pressed into a cosmic shoreline, our sun floats in a strange and solitary position, 55 light-years above the great disk of the Milky Way. The solar system drifts quietly as if held in the soft breath of something ancient, something patient. Astronomers once imagined the sun would sit exactly in the plane of the galaxy, moving with the crowd, obeying the geometry of stellar traffic. But instead it hovers above that bustling sheet of stars, like a lantern suspended from an invisible thread, glowing alone in a gentler corridor of space. As astrophysicist Sean Carroll once said, "The universe is under no obligation to make intuitive sense to us." And the sun's strange location is one of those quiet reminders that the cosmos writes its own rules. This elevation is not random, nor is it permanent. The sun is moving in a slow galactic dance, rising and falling across the Milky Way's thin disk on a cycle lasting nearly 26 million years. It is a motion so vast and unhurried that humanity has existed for only the smallest heartbeat of a single swing. And yet this oscillation touches everything that surrounds us. The galaxy pulls gently downward with the combined gravity of billions of stars and great rivers of dark matter, and the sun responds like a weight on a cosmic spring, drifting upward, then returning downward in a rhythm older than any mountain on Earth. When we imagine the sun's path through the galaxy, it is tempting to picture a neat circle, a tidy orbit. But reality is softer and stranger. The solar system is not simply going around the galaxy. It is weaving through it, rising and dipping like a ship carried on unseen tides. With each oscillation, it passes through regions of differing density, differing radiation, differing magnetic fields. As the astrophysicist Vera Rubin once noted, we see only a sliver of what shapes us. The sliver in this case is the recognition that our place in the galaxy is not static, but rather part of a long, slow breath the Milky Way has been taking for billions of years. The question that intrigues both scientists and storytellers is simple yet profound. How did our sun end up 55 light-years above the galactic plane? The answer lies in the combined gravitational forces from the disk and the halo, as well as chaotic influences from the early solar system's birth environment. In its youth, the sun was likely part of a star cluster, jostled by siblings, tugged by passing clouds of gas, shaped by the swirl of matter that once crowded the Milky Way's spiral arms. Over time, those interactions nudged the sun upward, giving it a gentle vertical drift that would later stretch into its present motion through the galaxy. This vertical displacement may seem trivial across the immensity of the Milky Way, yet it may have shaped the destiny of Earth and life itself. Because the galactic plane is crowded, bright, and dangerous. Closer to the midline lie denser clouds of gas, higher radiation environments, and more frequent supernova events. The sun's elevated position may have spared Earth from intense bursts of cosmic rays during its early development when the fragile chemistry of life was first forming. As Carl Sagan once reflected, we live in a universe where small differences can be everything. And perhaps this gentle separation from the galactic crowd was one of those quiet yet life-altering differences. But this safety is not permanent. The sun is not fixed above the plane. It is drifting slowly downward in its current phase of motion. In roughly 30 million years, it will cross the galactic plane again, entering a region denser than the one it currently inhabits. Each crossing exposes the solar system to gravitational disturbances capable of nudging the distant icy bodies in the Oort cloud, that vast spherical reservoir of comets stretching almost halfway to the nearest star. When the sun plunges through the crowded disk, tiny gravitational differences accumulate over millions of years, shaking loose, long, frozen objects and sending some inward on long, dramatic journeys toward the inner planets. It is a cosmic billiard game, neither hostile nor kind. Simply a matter of gravity doing what gravity always does. Some researchers have wondered whether these periodic disturbances could be linked to patterns in Earth's geological record, particularly extinction events. The idea was controversial from the moment it was proposed, and as newer data arrived, the supposed pattern faded under scrutiny. And yet the intuition remains compelling, that in the deep past Earth may have felt the breath of the galaxy press upon it in subtle but significant ways. As paleontologist David Raup once said in defense of bold questions, the universe is under no obligation to be simple. And so the possibility that cosmic motion touches biological history remains an open door, waiting for better evidence to step through it. Still, even without a dramatic link to mass extinctions, the periodic crossing of the galactic plane carries undeniable consequences for the solar system's outermost frontier. The Oort cloud is held in place not just by the Sun's gravity, but by the delicate balance between solar attraction and galactic tidal forces. When we pass through denser regions of the Milky Way, that balance shifts ever so slightly, enough to alter the paths of trillions of icy bodies drifting in darkness. Henry Norris Russell famously remarked, "The universe is vast and wider than our imagination." And nowhere is that more apparent than in this slow choreography between the Sun and the galaxy. A dance measured not in lifetimes but in eons. As we picture this long vertical journey, it becomes easy to romanticize the Sun as a wanderer, a quiet traveler crossing invisible boundaries in the darkness. But there is truth in the poetry. The Sun is moving through environments our species has never witnessed, slipping through vast regions of hot gas, magnetic fields, and dark matter streams as subtly as a feather gliding on a breeze. These transitions shape the heliosphere, the great bubble of solar wind that protects Earth from cosmic rays. When the Sun moves into denser galactic regions, the heliosphere contracts, allowing more high-energy particles to seep inward. When it enters emptier regions, the heliosphere expands, wrapping Earth in a thicker shield. It is a dynamic boundaries pulse, responding to the galaxy like a leaf responding to the river beneath it. Even the simple fact that the Sun is rising or falling carries implications for the future of astronomy, because as it moves through the galaxy, the view of the heavens slowly changes. Stars appear to shift their relative positions over deep time, constellations reshaping themselves across intervals far longer than recorded history. We are passengers inside a slow celestial elevator, drifting upward now, though someday drifting down again toward the denser heart of the Milky Way. In contemplating all this, one lesson comes gently into focus. The solar system is not an island, and Earth is not a still point in the void. We are part of a grander motion than we can feel, a motion too slow for the senses, yet too vast to ignore. The universe shapes us even when we are unaware of its touch, and perhaps that is the quiet beauty of our place in the cosmos. For me, the most humbling realization is that we inhabit a galaxy that is not static, but alive with motion and memory. Our Sun is not anchored, but drifting through environments sculpted by billions of years of stellar birth and death. And each rise or fall across the galactic plane is a reminder that change is woven into the structure of everything, from galaxies to living creatures. Neil deGrasse Tyson once said, "We are part of this universe. We are in this universe. But perhaps more important than both is that the universe is in us." And indeed, when we watch the slow oscillation of the Sun, it becomes clear that we carry within us the echoes of motions far older than human thought. So as we drift 55 light-years above the galactic plane, carried by the quiet breath of the Milky Way, let this truth settle gently into your mind. We are travelers in a cosmic tide, rising and falling across timescales too immense to fathom. Our home is not fixed, but sailing through the great river of our galaxy. And every oscillation is a reminder that existence itself is motion, and that life on Earth is just one delicate arrangement in a universe that is forever in flux. If you feel the wonder of this journey, Let your thoughts drift in the comments below, and share what this long galactic motion makes you imagine about our future. For in asking such questions, we continue the oldest human tradition of all, lifting our eyes to the stars and whispering to the darkness. Where are we going next? The farther we drift from the warmth of the sun, the more the galaxy reveals its invisible hands. Hands that pull, stretch, whisper, and sculpt the outermost edges of our solar system with a patience older than time itself. Astronomers call this force the galactic tide, but to me, it feels like the slow breathing of the Milky Way, a rise and fall so gentle that even 1 billion years cannot hurry it. The Oort cloud, a cold sphere of ancient ice that surrounds us like a memory half forgotten, obeys this breath. The galactic tide shapes the Oort cloud the way ocean tides shape abandoned coastlines, not with violence, but with steady persistence that never sleeps. Every tiny nucleus of a comet, every frozen shard older than Earth itself, moves slightly with each gravitational whisper from the galaxy. It is astonishing how something so weak, so faint, can command trillions of objects across spans of light years. But as the physicist John Wheeler once said, mass tells space-time how to curve, and space-time tells mass how to move. The galaxy curves space itself, and the Oort cloud obeys. Most people imagine our solar system as an island ruled solely by the sun. But far beyond Neptune, far beyond the Kuiper belt, sunlight fades into a whisper, and the sun becomes just one voice among many. Out there, the Milky Way speaks more loudly than our star. Its gravity stretches the Oort cloud like an old net drifting beneath cosmic tides. Some comets are nudged inward, their orbits slowly elongated until one day they begin the long fall toward the sun. Others are pulled outward, slipping beyond the final edge where the sun's embrace ends. This is why the galactic tide is powerful enough to send comets toward the inner solar system. Not because its pull is strong, but because the sun's hold becomes delicate at such extraordinary distances. Imagine a feather balanced on the wind. A gentle breeze can redirect its entire journey. The Oort cloud is made of feathers, and the galaxy is the wind. Some scientists once believed passing stars were the main reason comets fall toward the sun. But modern calculations tell a gentler and stranger truth. Passing stars are rare visitors, astrophysicist Jacques Lascar noted. But the galactic tide is always there, always pulling. It is the steady background force that slowly loads the cosmic slingshot, ready to send icy wanderers inward over millions of years. Yet there is another contributor, one even more mysterious. Dark matter, the invisible mass cradling our galaxy, strengthens the tidal pull by nearly 15%. 15% might seem small, but in a realm where gravity is already whispers and silk threads, that extra tug can be the difference between a comet sleeping in darkness or falling like a spark toward the sun. Physicist Catherine Fries once said, "Dark matter is the cosmic scaffolding upon which galaxies build themselves. If galaxies build upon that scaffolding, then so do their tides." Some astronomers even suspect that streams or clumps of dark matter pass through our region of the galaxy, subtly increasing the tidal tug on the Oort cloud during certain epochs. If true, the history of life on Earth might carry faint fingerprints of dark matter, encoded in the rhythm of ancient comet showers. I find that idea deeply humbling. That the rise and fall of species, the quiet branching of evolutionary paths, might whisper traces of something humanity cannot even see. When we talk about comets, we often speak with the tone of spectacle, bright tails, long orbits, ancient origins. But from a cosmic perspective, comets are messengers. They are born in the frozen silence at the edge of the sun's kingdom, and the galactic tide is the hand that sends them inward. Each comet that visits the inner solar system is a story pulled from the darkness, a fragment of the galaxy's memory. This makes the Oort cloud feel less like an isolated shell and more like a shoreline touched gently by the tides of the Milky Way. Every ripple in the galaxy, every motion of its stars, every hidden stream of dark matter shapes the destiny of those frozen worlds. And in return, some of those worlds shape ours. It is possible that comets delivered water to early Earth, or organic molecules that became the seeds of life. If so, then we owe our existence in part to the galactic tide. As I reflect on this, a quiet lesson emerges. Sometimes the greatest influences in life are not the forces that shout, but the ones that whisper slowly across long distances. The galactic tide is the embodiment of patience, shaping worlds with the softest hands imaginable. In a universe filled with explosions, ignition, and violent births of stars, it is comforting to know that gentleness can also sculpt destiny. And perhaps that is the deeper beauty of the galactic tide. It reminds us that small influences, applied across grand stretches of time, can change the course of entire systems. Just as in our own lives, subtle choices made consistently can redirect the trajectories of our futures. I find myself returning to a line from Carl Sagan, who wrote, "We are shaped by the cosmos, and in turn we shape our understanding of it." The galactic tide shapes us in ways we cannot feel, and yet we shape its story by daring to understand it. So when the next comet glides through the night sky, silent and silver like a thought crossing the mind of the universe, remember that it began its journey because the Milky Way breathed gently upon it. A tide you cannot see, a tide that never rests, a tide that connects us to the galaxy in the most delicate way imaginable. And perhaps, as we drift farther into the darkness ahead, the same tide will continue guiding us, reminding us that no matter how small our world may seem, we are woven into a much larger rhythm, a rhythm older than the stars, and patient enough to wait for us to listen. The space we call home is not empty. It breathes. It remembers. It echoes with the ghosts of stars that died before our species even learned to dream. When scientists speak about the local bubble, they often speak with a kind of reverent caution, as if describing a crime scene long gone cold yet still whispering clues into the cosmic dark. Imagine a cavity stretching 1,000 light-years across. a hollow carved, not gently but violently by the breath of 15 to 20 supernovae. This is where the sun drifts now, like a lantern hanging in the ruins of ancient fire. Inside this vast spherical wound, the temperature reaches 1,000,000 degrees Celsius. So hot that atoms shed their electrons and wander as pure ionized plasma. Yet the density is so low that you could travel for centuries through it and never touch enough atoms to warm your skin. Heat without touch, fire without flame. The paradox feels almost poetic. Astrophysicist Dr. Randall Smith once said, "The local bubble is both nothing and everything at the same time." A reminder that emptiness in the universe is never truly empty. I think about that line often, especially when remembering that our existence sits not in calm space, but in the heart of an old explosion frenzy. Science did not uncover this truth immediately. It came slowly, like dust settling onto an untouched floor. First, there were the maps of starlight, showing curious gaps in the distribution of dense clouds around us. Then, X-ray observations confirmed unusually hot gas in every direction. But it was not until geologists sliced into the seafloor that the story sharpened into something undeniable. Embedded within layers of ocean crust lay tiny traces of radioactive iron, 60, and plutonium-244. Isotopes that cannot form on Earth naturally. Isotopes young enough that they must have fallen on our world from nearby stellar detonations only a few million years ago. As physicist Dr. Anton Wallner noted, "It is as if the universe sprinkled confession letters across the Earth's oceans. These atoms carry timestamps, and the timestamps match precisely the era when the local bubble was inflating around us. When I picture this ancient arena, I imagine stars swelling at the ends of their lives, their cores collapsing, their outer layers hurled outward like blossoms of white-hot metal. Each supernova pushed the expanding bubble a little farther, sweeping away gas, compressing the surrounding medium, leaving behind a cavity so empty that scientists sometimes struggle to model it with ordinary assumptions. And yet, out of this devastation came one of the quiet gifts of cosmic evolution. A region of lower density can shape the development of nearby stellar nurseries, guiding the birth of new stars at its edge. Much like a wildfire clearing land allows a forest to grow back strangely renewed. But there is a deeper question here, almost philosophical. Did these supernovae influence Earth directly, not as apocalyptic blows, but as gentle shapers of destiny? Some researchers propose that increased cosmic rays during these periods may have affected climate or mutation rates. Not enough to erase life, but enough to subtly bend its path. I am reminded of the words of Carl Sagan. "We are star stuff, which has taken its destiny into its own hands." Yet perhaps it is equally true that long before we took destiny into our hands, stars took ours into theirs. The more I study the local bubble, the more it feels like a cradle built from destruction. Our sun happens to reside near the bubble's interior wall, not at its center, suggesting that we wandered into it rather than being born inside it. This wandering is not surprising, for the sun's orbit around the galaxy is not a perfect circle, nor a steady plane, but a gentle oscillation up and down through the Milky Way like a leaf drifting between ocean waves. As we drifted, We entered a space sculpted by ancient stellar deaths, and now we sail quietly through the afterglow of giants. Sometimes I imagine looking at our situation from far above the galaxy. The Milky Way's disk, thin and luminous, stretching out like a slow spiral of frost and silver. Our tiny star drifting in an invisible cavity within one of its arms, like a lantern suspended inside the hollow trunk of a tree struck by lightning long ago. The perspective makes one feel small, yet deeply connected. Connected to the dead stars whose ashes now form our blood, our bones, our oceans. Connected to the violent convulsions of a cosmos that does not apologize for its beauty or its brutality. Even the temperature of the local bubble speaks in contradictions. 1,000,000 degrees is enough to ionize atoms completely. But there is so little material that the concept of heat becomes strange. You would not burn in such a place, because there is nothing to touch you. The heat is a whisper, not a flame. A record of old energy that refuses to fade. Dr. Juna Kohlmeier once described the bubble's interior as a cathedral of invisible fire. And I find that phrase lingers in the mind like incense. But among all these facts, among all these measurements and maps, something else remains. Something quieter. The local bubble is a reminder that cosmic violence and cosmic serenity often coexist. We live inside the aftermath of destruction. Yet we experience a sky so peaceful that children fall asleep beneath it without fear. What a strange duality. What a humbling truth. If there is a lesson here, perhaps it is this. The universe is not merely a sequence of catastrophic events, but a series of transformations that allow new forms to emerge. Life on Earth, fragile and improbable, blossomed in a region shaped by explosions that could have ended it. Yet those explosions unfolded millions of years before life grew complex, leaving behind a haven more open to starlight, less clouded, more tranquil in radiation than the dense spiral arms where supernovae still detonate frequently. I often think about how human beings react to this kind of knowledge. Some feel fear, imagining the violence that once raged here. Others feel awe, recognizing how improbable it is that life evolved in such a place. But the emotion I feel most is gratitude. Gratitude toward the long chain of cosmic events that cleared this space, allowed the sun to drift in, and gave Earth the calm and time it needed to dream itself awake. When the next supernova in our region eventually detonates, and one will, someday, its light will blaze across our sky, and humanity will feel once again how fragile we are under the rhythms of the galaxy. But for now, we float gently in the last breath of explosions older than our lineage, drifting through an emptiness warm with ancient memory. And in this drifting, perhaps we can reflect on how creation and destruction endlessly interlace. How the universe does not choose one over the other, but weaves both into the fabric of everything. As we continue this journey through the cosmic neighborhood above and below the solar system, I invite you to hold this image close. The image of your life unfolding inside a hollow sculpted by dead stars. If this thought stirs wonder in you, or fear, or a quiet longing to understand more, share your reflection in the comments. Let your voice join this ancient conversation between light, dust, and time. For beyond the local bubble, beyond the warmth of this invisible cathedral, the galaxy stretches into mysteries deeper still, and we are only beginning to drift toward them. The farther we drift into the quiet interior of the local bubble, the more we realize that space is not the calm void our ancestors imagined. It breathes. It trembles. It remembers the violence that carved it. And within that ancient wound of 1,000,000 degrees, a mystery lingers like a delicate pulse in the dark. The north of this enormous cavity glows warm, but the south burns almost 50% hotter. A gradient so vast, so asymmetrical, that even seasoned astronomers pause before its silent contradiction. Nature rarely creates imbalance without leaving a signature. Astrophysicist Randall Smith once said, and, indeed, the local bubble feels like a message etched in temperature. A cosmic scar whose left and right halves never healed the same way. When I first studied this asymmetry, I felt as though I had placed my ear on the chest of the galaxy itself, listening for a heartbeat that had gone unnoticed for millions of years. The north whispers, warm and steady. The south exhales a sharper heat, more urgent, almost as if some ancient flame still lingers there. Scientists have offered explanations, but each feels like a lantern illuminating only part of a cavern whose true size remains hidden. Some say the supernovae that carved the bubble did not detonate evenly. A cluster of explosions to the south could have poured more energy into that hemisphere, scorching it with an intensity that still radiates today. As astronomer J. Subhong remarked, supernovae are not fireworks arranged in perfect symmetry. They are tectonic events in the sky. If several of those stars collapsed closer together, or at slightly different depths within the primordial cloud that once filled this region, the shock waves would naturally grow lopsided. But there is another possibility, that the southern half of the local bubble encountered a denser pocket of interstellar gas long ago. When supernova shock fronts collide with uneven surroundings, they heat some regions more deeply than others. The gas resists, compresses, and ultimately ignites into higher temperatures as the shock tears through it. Still others imagine a late explosion, a final dying star that detonated slightly off-center, injecting fresh heat into the southern arc long after its northern siblings had gone cold. If this were true, the gradient is not merely a fossil, but a timestamp, a cosmic memory of the last great death in our neighborhood. As I reflect on these possibilities, I find myself drawn to a deeper thought. The notion that asymmetry itself is the universe's handwriting. We expect balance, perfection, but space evolves like a living organism, shaped by accidents, traumas, and the unpredictable rhythms of time. Consider how heat spreads in a forest after a wildfire. Some trunks are charred to ash, while others stand strangely untouched. The local bubble may simply be the forest left behind. Its northern boughs cooled, its southern roots still glowing with the remnants of old fire. When the Rosetta X-ray telescope mapped the bubble, astronomers were startled not only by the temperature gap, but by its stubborn clarity. It was not a measurement error, not an artifact of instruments. It was real, as real as the air you breathe, yet stretching across distances that dwarf imagination. And so we return to the ancient explosions, to the titanic stars whose deaths gave birth to the space we inhabit. Some must have erupted more violently in the south, shaping that hemisphere with bursts strong enough to heat gas to 1,000,000 degrees. I often imagine those stars in their last moments, swollen giants trembling under the weight of their own gravity, cores collapsing in fractions of a second, shells suspended in impossible stillness before a shockwave hurled them outward faster than thought. Each one a sun many times more massive than ours. Each detonation an event bright enough to outshine entire galaxies for an instant. Perhaps several collapsed almost as siblings, their deaths overlapping, creating a southern storm so intense that even millions of years later, the heat has not dissipated. Or perhaps the northern region once held more gas to absorb the energy, cushioning the blast, leaving the south to take the brunt of the violence. Whatever the cause, the result is a cosmic imbalance that still glows around us. I am reminded of a line by the late astronomer John Bally, who wrote, "Supernovae do not simply light the galaxy. They sculpt it." And indeed, the local bubble feels sculpted, chiseled by invisible hands, warmed unevenly by fires we never saw, but whose heat we still inhabit. What fascinates me most is not merely the physics, but the intimacy of our position. We do not circle outside this structure, observing it safely from afar. We live inside it, drifting like a tiny boat in the eye of an ancient storm. The warm north presses upon us. The hotter south breathes beneath. And we glide between them, unaware for human lifetimes that such forces cradle our existence. To think that early humans wandered the plains of Africa while the gas around our solar system still shimmered with newborn heat. That our species arose in the aftermath of a celestial chain reaction. That our atmosphere once absorbed the faint radioactivity of those same supernovae humbles me deeply. In the quiet of late nights, when telescopes sleep and the sky feels like a vast bowl of dark water, I reflect on what this gradient teaches. That the universe does not strive for symmetry. It simply evolves, leaving behind the uneven fingerprints of its own history. And perhaps there is a lesson for us, whispered through 1,000,000-degree wind. That beauty often lies in imbalance. That scars tell stories. That nothing born of violence returns to perfect harmony. The local bubble is not a clean sphere, not a uniform cauldron. It is a memory palace of stellar death. One room warm, another aflame. And we occupy its middle corridor, walking quietly among the echoes. And so I leave you with a thought. If the sky above your head could speak, it would not sing a single unified song. It would hum with uneven notes, the northern tones soft and golden, the southern chords sharper, hotter, remnants of fires that once shook the galaxy. And we, #0, 5# is greater than we, are the listeners, the wanderers, the fragile beings floating in a warm and uneven cradle carved by ancient light. If you have your own theory, your own intuition, or simply a feeling stirred by the thought that our cosmic home is hotter on one side than the other, share it in the comments. Every voice is a star in this conversation, and every question is a doorway deeper into the mystery. And as we drift onward together, let us follow the temperature southward, into the brighter burn, where the story of uneven creation waits for us to listen a little longer. The local interstellar cloud is not merely a region of drifting atoms. It is a soft cradle of warm gas that our solar system entered tens of thousands of years ago. Astronomers estimate that we crossed its invisible boundary somewhere between 40,000 and 150,000 years in the past. A span long enough to feel ancient yet recent in the life of a star. When I think of that moment, I imagine our sun as a lone traveler stepping through a shimmering veil, its heliosphere brushing against a cosmic doorway that no creature on Earth could ever perceive with their own senses. The physicist Bruce Drain once said that the interstellar medium is the ocean in which every star must swim. And in this quiet truth lies the beginning of our story. The local interstellar cloud itself is warm, gentle even, at around 7,000 degrees Kelvin, yet so thin that a cubic centimeter of air on Earth holds 10 billion times more particles than the same volume in this cloud. And through this near emptiness flows the local interstellar wind, a stream of atoms moving past our heliosphere at roughly 16 kilometers every second. 16 kilometers per second, and yet it feels like a whisper. A whisper brushing against the outer skin of our solar system, shaping it, sculpting it, pressing and stretching the heliosphere like the breath of a sleeping giant shaping the veil around its face. The heliosphere is our shield, the great bubble carved by the sun's constant outflow of charged particles. But a bubble is only as strong as the environment it moves through. And as the interstellar wind streams past us, it pushes the heliosphere inward on the upstream side and allows it to stretch farther on the downstream side. This asymmetry is not just geometry. It is a living conversation between the sun and the galaxy. Heliophysicist Merov Ofer once remarked, "The shape of the heliosphere tells us who we are in the galaxy." And there is something profoundly human in that thought. As we drift inside the local interstellar cloud, every particle that enters the heliosphere, every ion that slips through the sun's magnetic breath, becomes part of a larger story of cosmic influences interacting with the delicate envelope that protects Earth. More interstellar gas can compress the heliosphere, reducing its ability to shelter us from galactic cosmic rays. Fewer particles can allow it to expand, giving us a wider shield. It is a breathing boundary, expanding and contracting like the chest of a sleeping creature. And yet, the local interstellar cloud is not our forever home. We are merely passing through, like a traveler moving between valleys at twilight. Our solar system continues its orbit around the Milky Way, sweeping through regions of differing density, temperature, magnetism. Scientists predict that within 10,000 to 50,000 years, depending on which boundary lies ahead, we will leave this cloud entirely and slip into a new interstellar region. Where will that path lead us? Into a denser cloud, or into a vast hollow like the local bubble? Each possibility carries its own quiet story. If we enter a denser interstellar cloud, the heliosphere may shrink significantly. More cosmic rays could seep into the inner solar system, touching Mars, brushing against the atmospheres of the outer planets, and reaching Earth with a strength unseen in our current era. Jim Green from NASA once reflected, "Space weather is not only shaped by the sun, but by the galaxy itself." In that single sentence lies the fragile truth that our sun is not the sole architect of our environment. It is only one voice in a quiet symphony conducted by the Milky Way. If we exit into a more rarefied region, the heliosphere might blossom outward, stretching farther into interstellar space. A larger shield, a gentler wind, a quieter cosmic climate for future Earths to orbit within. But even this cannot be predicted with full certainty, because the galaxy is vast, and the cartography of interstellar clouds is still incomplete. We are ancient explorers without a map, guided only by the faint signals captured by spacecraft like Voyager and Ibex. When I imagine our ancestors, early humans wandering across the plains of Africa, their lives lit by firelight and starlight, I think of the quiet truth that they lived under a sun already entering this interstellar cloud. They had no words for it, no instruments, no theories. Yet above them, the heliosphere was subtly reshaped by the medium it drifted through. The cosmic environment of Earth was already changing, the protective boundaries shifting as silently as the tides of the sea. The astrophysicist Carl Sagan once wrote, "We are adrift in a great ocean of space, and it has left its imprint upon us." His words feel truer than ever as we contemplate our passage through this cloud. There is also something deeply humbling in recognizing that humanity's entire written history, every story, every empire, every dream, unfolded while our solar system was gliding through a cloud unknown to us. It reminds me that the galaxy is not a distant concept, but a shaping force, a great sculptor whispering at the edge of our reality. The interstellar wind at 16 kilometers per second may sound thrilling, yet in truth it moves with the softness of breath. It nudges the heliosphere gently, just enough to remind us that the sun is not alone in its dominion, that even a star must bow to the pressure of the medium around it. In a way, it is a lesson for us. We too are shaped by the environment through which we pass, by the currents of time, by the unseen winds of our own histories. One of the most beautiful lessons we can take from this cosmic journey is the understanding that change is not an interruption. It is the natural way of the universe. Just as the heliosphere flexes and adapts to the interstellar wind, we too must learn to bend, to shift, to accept the invisible pressures that shape our lives. The galaxy does not resist its own evolution, and perhaps that is the quiet wisdom it offers us. Another lesson lies in humility. For as we glide through the local interstellar cloud, we are reminded that our solar system is not a kingdom, but a traveler, a wandering lantern drifting through a cathedral of gas and dust, carrying within it the fragile oasis we call home. Astrophysicist Avi Loeb phrased it gently when he said, "We are not the center of the cosmic story. We are a chapter within it." And indeed, the local interstellar cloud is simply one page in the long book of our voyage around the Milky Way. As for when we will leave this cloud, the truth remains uncertain. The boundaries are diffuse, the edges blurred like watercolor spilling across paper, and our measurements, though growing sharper, are still incomplete. But whether the moment is 10,000 years away or 50,000, we know we will cross into a new region, a new state of cosmic weather, a new dialogue with the galaxy. And when that happens, the heliosphere will change once more, breathing deeper or shallower depending on what awaits us. In this drifting, wandering, almost meditative journey through the galaxy, I find a quiet comfort. The universe is not static, and neither are we. Every moment that Earth has existed, it has been touched by forces larger than our dreams. And yet, despite these silent cosmic winds, life grew, consciousness awakened, and we became capable of asking these questions. That alone is a miracle. So as we glide through the local interstellar cloud, carried gently by the sun's magnetic breath, wrapped in the soft whisper of the interstellar wind, let us remember that we are passengers in a grand journey. A journey filled with unknown turns, invisible landscapes, and cosmic currents that long predate us. And perhaps the greatest lesson is this: that we are part of the universe not because we stand still within it, but because we move with it. Always drifting, always learning, always carried forward by winds we cannot see. The edge of the sun's breath is not where you think it is. For most of human history, we imagined our star blowing its warmth outward forever, filling the darkness with its invisible wind as if nothing could oppose it. But the universe is patient, and far beyond the last planet something waits. A boundary neither soft nor sharp, a trembling skin where the sun's influence finally ends. Astronomers call it the heliopause, yet the name barely captures its quiet power. When I picture this outer border, I imagine a shell of light around a candle placed in a storm. The sun breathes outward in all directions, its solar wind pushing fiercely at first, then weakening little by little until the winds of the galaxy push back. Where these two forces meet, where the sun can rise no further, that is the heliopause. Many once assumed this boundary must be a perfect sphere, neat and elegant, like a bubble drifting in cosmic water. But nature rarely draws circles for our convenience. As data from Voyager 1 and Voyager 2 flowed home across the cold void, scientists discovered something more complex. The heliopause is not round, not symmetrical, and certainly not polite. It is indented on the side facing our motion through the galaxy, softened and compressed like fabric pulled against the wind. Astrophysicist Merav Ofer once said, "The heliosphere is not the sun's fortress. It is the galaxy's sculpture." Her words echo each time we examine that strange frontier. We are not the ones shaping it. We are the ones being shaped. The Voyagers became our messengers in this revelation. Voyager 1. Small enough to hold in one human room, yet brave enough to outlive worlds, coasted outward for 35 years before touching the line between star and interstellar darkness. On August 25, 2012, it crossed the heliopause. There was no flash, no tremor, just a sudden shift in the rhythm of particles, striking its thin metallic skin. Solar wind fell silent. Cosmic rays surged in. The spacecraft had stepped out of the sun's cradle. And years later, Voyager 2 confirmed the truth with its own quiet crossing. Both travelers recorded something almost poetic. A place where the sun's voice fades and the galaxy begins to speak. The data shocked scientists because the boundary was sharper than expected. A knife edge rather than a soft blend. It was as if the universe were drawing a deliberate line, telling us where one realm ends and another begins. A Nobel physicist once whispered in an interview, "Crossing the heliopause is crossing the skin of the sun." That phrase lingered in me. The skin of the sun, stretched to 121 astronomical units. Thin, trembling, but present. Imagine standing on a quiet shore, feeling the tide pull at your ankles. Beyond that line, the ocean belongs to something else. That is how the heliopause holds us. But even this analogy falls short because the heliosphere breathes. It expands during solar maximum when the sun's magnetic fields roar in tangled storms, and contracts when the sun grows quiet. Like a living heart, it pulses through cosmic time. Voyager saw these breaths in the shifting pressures pressing against its instruments. It recorded waves rolling across the boundary, vibrations from distant supernovae that took centuries to reach us. Ed Stone, the gentle voice guiding the Voyager mission for decades, once reflected, "Interstellar space is not silent. It is playing a very slow symphony." And truly, the Voyagers heard it. The magnetic fields beyond the heliopause do not behave like ours. They twist softly, slanting in directions that puzzled researchers for years. Voyager 1 detected barely a change in field orientation at first, as though the galactic magnetic field had leaned down and aligned itself with the sun's like two old friends matching steps. But deeper readings showed subtle differences, quiet clues that we were no longer in the sun's domain. This thin haze of magnetism, almost undetectable, is the whisper of the Milky Way itself. When I think about this frontier, I feel a profound humility. We imagine ourselves explorers, but in truth we are seeds blown on cosmic wind. The heliopause is not a destination. It is a reminder. A reminder that every boundary we cross reveals another boundary further beyond. The Voyagers did not show us how far we have come. They showed us how far there is still to go. And perhaps the most poetic detail of all is this. The sun's gravity continues far beyond the heliopause, stretching like a parent's unseen hand guiding a child long after the child wanders beyond sight. The planets orbit within 50 astronomical units. The Kuiper belt reaches 100, but the sun's gravitational loyalty extends nearly 2 light years. Only at the tidal truncation radius does the galaxy finally claim dominion. The Voyagers crossed the edge of the sun's breath, but not the edge of the sun's hold. In a way, that duality reflects our own lives. We step beyond familiar boundaries, leave home, cross into new spaces that feel foreign. Yet invisible threads still bind us to where we began. The Voyagers remind us that exploration is not escape, but expansion. Sometimes I imagine the spacecraft drifting there now, alone, coated in cosmic dust. The sun dims behind them, no longer the fierce guardian it once was. Ahead stretches a darkness older than any human dream. Yet what moves me most is not their distance but their persistence. Fragile machines, built by hands that tremble, flung into a void that does not care whether they live or die. And still they send their faint electric heartbeat across the abyss. Still they speak. Still they try. The cosmos is vast, but meaning is made by small things that endure. I often return to the words of Carl Sagan, who helped conceive the Voyager's message to the stars. He once said, "The open road still softly calls, inviting us to explore." And in the Voyager's slow flight, I feel that call unfolding endlessly. For me, the lesson is simple yet profound. Boundaries are real, but they are not walls. The heliopause is not the end of the sun, nor the beginning of the galaxy. It is merely one breath meeting another, one influence surrendering to a larger one. Just as we must sometimes surrender to forces greater than ourselves. If you listen closely, you can almost hear the Voyagers drifting beyond language, beyond ownership, beyond fear. Out there, where the sun stops singing, the galaxy hums its deeper tune. A tune we have only just begun to hear. And so, as this story settles into you like cosmic dust on a quiet surface, I ask you to share your own thought in the comments. What does it mean to you that humanity has already placed a hand in interstellar space? That we have touched the border between the familiar and the infinite? Your voice is part of this great unfolding. And like the Voyagers, every whisper matters. The farther we journey from the familiar warmth of the inner solar system, the more the universe begins to whisper in a different language. A softer voice, older than planets, older even than the sun itself. And at the edge of that whisper lies a place we have never seen yet understand more deeply than many things we can touch. The Oort cloud, that ghostly sphere of frozen wanderers drifting so far from the sun that its light arrives like a memory rather than a flame. Physically invisible yet scientifically undeniable. The Oort cloud is the farthest frontier of the solar system. And tucked inside it like the secret heart of a secret realm is the Hills cloud. Quieter, denser, and strangely more loyal to the sun than anything that far out should be. Together they form the last breath of our star's gravitational authority. The place where the sun whispers rather than commands. Astronomers often say that to understand the universe, we must first learn to trust what cannot be directly seen. The Oort cloud is the perfect test of that trust. Jan Oort himself once wrote that absence of evidence is never evidence of absence. A gentle yet powerful reminder that the cosmos is under no obligation to reveal itself in the wavelengths we prefer. We have never detected a single Oort cloud object directly. Not because they are myths, but because they are too small, too dark, and too far for any telescope to grasp. Yet their fingerprints arrive in the form of long-period comets, icy messengers whose orbits stretch across millions of years. They fall inward from every direction, not from the flat plane of planetary motion but from a full celestial sphere. Only a reservoir shaped like a bubble across the darkness could release comets in such a pattern. The shape speaks when the objects cannot. But the Oort cloud holds a deeper mystery. By all simple logic, it should no longer exist. Over billions of years, the tides of the galaxy pull on it relentlessly. A gentle stretching and squeezing caused by the Milky Way's mass. Passing stars drift close enough to shake its outermost members free, sending them out into the interstellar dark or hurling them inward toward the sun. If the Oort cloud were only what we first imagined, it would have eroded away long ago. Empty as a forgotten shell, yet it lives. And it lives because it has help from within. The Hills cloud, proposed by Jack Hills, is that hidden inner sanctuary. A donut of icy bodies more tightly bound than their distant siblings. Hills once remarked that the universe rarely wastes structure. A poetic truth disguised as scientific insight. The Hills cloud acts as a reservoir that constantly repopulates the Oort cloud, replacing what the galaxy erases. It is the quiet engine that keeps the solar system's farthest frontier alive. There is a strange tenderness in this. The idea that even the most exiled objects, drifting in the coldest distances, are part of a larger conversation. A balance maintained across timescales older than continents or species. The Hills cloud whispers renewal. The Oort cloud whispers endurance. And beyond both lies a border no object can cross without losing the sun forever. The tidal truncation radius. The place where the sun's gravity becomes equal to the galaxy's patient pull. Beyond that, no orbit can remain bound, no matter how loyal. It is the final goodbye of the solar system. Michio Kaku once said, "To understand the cosmos is to understand that we are held together by delicate forces across impossible distances." At the tidal boundary, you feel that delicacy most keenly. The sun's voice softens below a whisper, and objects begin listening instead to the Milky Way. Stars passing in the deep night exhale their gravity onto this fragile frontier. The galactic tide pulls. The sun pulls. And every icy relic must decide which master to follow. In this balancing act, in this fragile dance of gravitational loyalties, lies a lesson I find deeply human. The farther something travels from its origin, the harder it becomes to remain connected. The Oort cloud is not just a shell of icy bodies. It is a metaphor made of frozen dust, reminding us that relationships, systems, and histories all have boundaries where influence fades and new forces take over. Even stars must eventually release their hold. And yet, what amazes me most is not the inevitability of that release, but the sheer persistence of the sun's reach. Across nearly 1 trillion kilometers, its presence still matters. Even in exile, the comet remembers the star that birthed the solar system. Even at the edge of interstellar night, the sun's hand is still felt. Weak, trembling, but unmistakably there. When long-period comets fall inward, I imagine them as wanderers returning home. They cross the tidal threshold, slip back under the sun's spell, and dive inward across epochs. Some perish in its heat. Some are slingshotted away. Some leave scars on planets. But all of them carry stories of places we cannot see. A comet's nucleus is a frozen diary. Pages written when the solar system was still only dust and flame. Every time we study one, we read a line from the universe's earliest memories. There is something profoundly peaceful about imagining the solar system not as a collection of orbits, but as a family of relationships is less than pores, is greater than born from the same collapse of the same interstellar cloud. The Oort cloud is the oldest child who moved far away but never completely cut the bond. The Hills cloud is the quiet sibling who never left, always replenishing, always holding the memory of home. And the tidal boundary is the threshold between belonging and becoming something new. Carl Sagan once whispered into the world that we inhabit a universe of transformations. And nowhere is that more evident than at the edge of the sun's reach. Objects come and go. Influence fades. New forces take hold. Yet the structure as a whole persists. This, to me, is one of the universe's great teachings. Change does not destroy identity. It simply reshapes its borders. As I reflect on the Oort cloud, I realize it is a reminder that we too are held by forces we cannot see, shaped by events we never witnessed, influenced by tides that operate far beyond our understanding. We are not so different from those icy travelers, wandering yet still held by quiet gravities. Perhaps that is why the study of distant comets feels strangely intimate. What lies above and below the solar system is not isolation but connection. Not emptiness but structure. And at the farthest edge of the sun's light, where the warmth becomes a whisper and the whisper becomes memory, the Oort cloud and Hills cloud drift in cosmic meditation, guardians of the boundary between our home and the vast unknown beyond. If you feel something stir in your thoughts, some mixture of awe and melancholy, share it with me in the comments. Tell me what you imagine at the edge of the solar system, what you believe waits beyond the reach of our star. The conversation itself becomes a kind of gravity, binding us for a moment across the darkness. The first time I learned that the Milky Way is wrapped in an invisible halo of matter we cannot touch or see, I felt as though someone had quietly lifted the roof of reality and shown me the machinery above. In that moment, the galaxy no longer seemed like a serene pinwheel of stars drifting through darkness, but a living creature encased in a ghostly membrane, a skin made of something older than light itself. Dark matter. They call it a name that does not try to explain but simply admits our ignorance with a kind of reverence. Physicist Vera Rubin once said that we are made of the ordinary elements, but our galaxy is held together by something extraordinary. Her voice echoes in every discussion of the halo because she was one of the first to measure the strange behavior of rotating galaxies and declare to the world that there must be more mass than meets the eye. Much more. What she discovered was radical, not because it changed numbers in an equation, but because it changed the way we see ourselves in the cosmic story ever since. Imagine the Milky Way drifting like a luminous lotus on a hidden cosmic lake. Around it stretches a colossal sphere of invisible matter, hundreds of thousands of light years wide. This sphere is not empty, nor is it smooth. It is an ocean of ghost particles moving in cold, silent currents. And within that ocean are places where the currents converge, where dark matter folds into itself and forms dense sheets and rings. These are the caustics, the scars of ancient galactic formation. Some call them gravitational whispers, others dark shells, and some simply creases in the cosmic fabric. But all agree that where dark matter gathers, gravity intensifies. And where gravity intensifies, the solar system can feel the touch, even from tens of thousands of light years away. I often think of the Oort cloud in this context, that fragile kingdom of icy wanderers surrounding our sun in a sphere so vast it dwarfs everything we know. These comets, frozen relics from the dawn of the solar system, drift silently at the border between our sun's influence and the galaxy's tidal pull. They are like ancient monks, meditating in the outer dark, waiting for something to disturb their long cosmic silence. And dark matter does disturb them. Gently, relentlessly, the dark halo breathes gravity into their orbits, sometimes pushing them outward, sometimes drawing them inward. The Oort cloud is not a peaceful snow globe, but a shimmering membrane vibrating with the faint music of galactic tides. Astrophysicist Lisa Randall once remarked that dark matter is not just a passive backdrop, but a dynamic participant in shaping the world we see. Her words fit the Oort cloud perfectly, because that distant region is where the galaxy and the solar system negotiate their boundaries. Every moment. Now imagine what happens when the solar system moves not just through dark matter itself, but through one of its dense rings. These caustic rings are not mystical fantasies, but mathematical predictions arising from how cold dark matter collapses under gravity during galaxy formation. They are the fossilized waves of an ancient cosmic dance, frozen into patterns that persist for billions of years. When our solar system passes through one such region, the gravitational pull on the Oort cloud subtly intensifies, enough to shake loose comets that have been untouched for ages. Some drift inward, tracing slow and graceful spirals toward the sun. Others fall in sudden plunges, like arrows of ancient time shot across unimaginable distances. It is here that the possibility of a comet shower emerges, a storm that may come once in hundreds of millions of years. This is not science fiction, but a hypothesis taken seriously by researchers who study the timing of past impacts. There may be no regular pattern, no cosmic heartbeat that dictates extinctions. But the idea that dark matter structures could occasionally influence comet dynamics is not dismissed. It is considered with cautious curiosity. I find that both humbling and strangely comforting. It reminds me that the galaxy is not a static machine, but a living system in motion. The invisible can shape the visible. The silent can influence the loud. The distant can reshape the world beneath our feet. Sometimes, when I describe the dark matter halo to people unfamiliar with astronomy, they imagine something violent or ominous. But to me, the halo feels more like a cosmic embrace, an unseen arm around the Milky Way, holding its stars in a slow, eternal swirl. Without dark matter, our galaxy would simply unravel into darkness, its stars drifting apart like ash blown from a dying fire. As physicist Nima Arkani Hamed said, "The universe is not only stranger than we think, it's stranger than we can think." His words resonate deeply when we speak of dark matter, because this halo is not merely a structure, but a reminder that we stand on the shoreline of a vast ocean of the unknown. Sometimes I picture the solar system as a small lantern floating inside this invisible sea, its warm glow surrounded by tides we cannot sense, yet which never stop shaping our journey around the galaxy. Above us, below us, in all directions, the halo stretches like an endless cathedral of silence. And somewhere within that quiet temple, the caustic rings weave their invisible geometry. There is a kind of poetry in imagining that life on Earth may have been influenced not just by the sun and planets, but by structures of matter we cannot detect directly. Matter that neither shines nor absorbs light. Perhaps a comet that set the stage for life, or one that ended an age of ancient creatures, began its journey because the solar system drifted into a region sculpted by dark matter. The boundary between science and myth sometimes blurs in these reflections. Not because the science is uncertain, but because the scale of the story is so vast that human language strains to hold it. To say that dark matter influences comet orbits is technically correct, yet it fails to capture the quiet drama of what that means. It means the galaxy breathes into the solar system, nudging frozen relics of creation across millions of years until one finally catches the sun's light and becomes a comet streaking across our skies. It means the history of Earth is entangled with the invisible architecture of the Milky Way. From my own perspective, contemplating the dark matter halo is a lesson in humility, a reminder that what we see is only a fraction of what shapes our existence. The world feels solid, the sky clear, the stars predictable. Yet, almost all the mass in the galaxy lies beyond sight, working in silence, patient as eternity. It teaches me to appreciate uncertainty not as a failure of knowledge, but as an invitation, a door into deeper wonder. For when we admit how little we know, the universe becomes vast again, and we become students of the infinite. In the end, the dark matter halo and its caustic rings remind us that reality is layered, woven from threads both visible and unseen. That the sun's path around the galaxy is not solitary, but guided by forces older than stars. That the Oort cloud, that icy monastery at the edge of the solar system, listens always to the whispers of the halo. And perhaps, as our spacecraft travel farther and our instruments grow sharper, we will one day touch the border between the known and the hidden, and finally feel the presence that holds our galaxy in its silent embrace. Until then, we drift, lanterns on a dark sea, guided by gravity's invisible hand. And maybe that is enough. Because sometimes, not knowing the whole story is what keeps the cosmos alive in our imagination, inviting us to look up with curiosity and wonder what else lies waiting in the dark. A faint glow hangs above the Milky Way, a veil of million-degree plasma stretching thousands of light-years in every direction. When I close my eyes and imagine drifting through that incandescent ocean, I often wonder how few people realize that our galaxy breathes heat into the void like a living creature. Some call it the galactic halo. Others call it the missing furnace of baryonic matter. But to me, It feels like the soft heartbeat of the cosmos. A whisper of origin stories written in temperatures no human could withstand. Astronomers once puzzled over the strange absence of ordinary matter in the universe. The equations said it should be here, woven into the galaxy's fabric. Yet starlight could only account for a fraction of what theory demanded. It was as if someone had stolen half the atoms from creation, scattering them into shadows beyond reach. Then came the discovery of the halo, a vast envelope of hot gas glowing silently in X-rays. Suddenly the mystery softened, revealing that the missing matter was never missing at all. It had simply risen above and below the galactic disk, suspended in a celestial heat that rivals the hearts of dying stars. When I imagine traveling through this halo, I feel as though I am floating inside the memory of supernovae. Their explosions did not just illuminate the skies of long-dead epochs. They carved fountains of energy that burst upward and downward through the galaxy's skin. Each eruption hurled metals and shockwaves into the halo, heating the gas to more than 1 million degrees Kelvin. This is not a gentle warmth, but the boiling breath of stars that lived fast and died young. It is extraordinary to think that those furious deaths now hold the secret of our missing baryons. Astrophysicist Joel Bregman once said, "If you want to understand where a galaxy hides its mass, look not at the stars, but at the space between them." His words echo in my thoughts whenever I contemplate the halo, because he is right. The true structure of a galaxy is not drawn by the constellations we admire, but by the invisible rivers of heat that flow through the darkness. The northern and southern reaches of the Milky Way tell two different stories. The halo is not uniform, not symmetrical, not obedient to the quiet order we wish the universe had. The north glows with a cooler sheen, as though it exhaled earlier, while the south pulses hotter, thicker, bearing the imprint of younger or more powerful eruptions. Asymmetry is the signature of history, astrophysicist Karin Sandstrom once remarked. And truly, the halo's imbalance is history, frozen in temperature. A reminder that the galaxy does not evolve gracefully, but violently, with bursts that push matter to the poles, like storms rumbling through a cosmic atmosphere. The halo itself is made not of gentle gas, but of plasma stripped bare of electrons in the furnace of supernova shock fronts. It swirls above the Milky Way like a crown of fire, its tendrils drifting outward for hundreds of thousands of light years. Yet, despite its immensity, the gas is so diffuse that a handful of atoms could fill a room the size of Earth's oceans. This paradox has always humbled me. Great volumes that weigh nearly nothing, fragile threads of matter weaving the skeleton of a galaxy. It teaches me that cosmic significance is not measured by density, but by influence. As the halo rises above us, it collides gently with the galactic winds streaming from star-forming regions. These vertical chimneys of gas are sculpted by clusters of young stars tearing themselves open in supernovae, sending their ashes upward like incense rising from a cosmic altar. The halo receives those ashes, cradles them, mixes them into its ancient body. It becomes the library where the elemental history of the galaxy is stored, not as pages, but as temperatures and ionization states. I often think of the halo as a guardian, a translucent shield that catches the fallout of stellar violence before it rains back into the disk where planets and life reside. Yet it is also a reminder that galaxies are restless, forever cycling gas from disk to halo and back. "The universe is not a static painting," said astrophysicist Juna Kollmeier. "It is a living engine." Her words feel especially true here, where hot gas slowly cools over millions of years, falling back toward the disk, like rain returning to the sea. This circulation of matter has profound consequences. Without it, the galaxy would exhaust its fuel for star formation, locking its future into a long twilight. But because of the halo, metals forged in ancient stars eventually find their way back to the galactic plane, feeding new generations of suns, planets, and perhaps life itself. In this way, the halo is both a graveyard and a cradle. Above the North Galactic Pole, the halo stretches into the great bubbles discovered by X-ray telescopes, enormous lobes of superheated gas that extend tens of thousands of light-years. These structures, likely sculpted by an ancient outburst from the Milky Way's central black hole, serve as colossal monuments to a time when the galaxy's heart beat with far more ferocity than today. Their edges glow with shock fronts, crisp, sharp, like the rim of a cosmic wave frozen in place. To drift near such a boundary in imagination is to hover beside a scar of unimaginable scale. The Fermi bubbles, as they are called, remind me that galactic halos are not passive husks, but active participants in the cosmic story. They carry the aftershocks of black hole accretion, the roar of winds from starbursts, and the patient simmer of gas falling inward from intergalactic space. Through all of this, the halo offers a lesson that feels deeply human to me. We often think the quietest parts of ourselves contain nothing, when in reality those places hold the heat of every storm we have survived. The galaxy's halo is the same, a silent reservoir holding the aftermath of stellar catastrophes, transmuting them into something that sustains future generations. When astronomers realized that much of the universe's baryonic matter lived in halos, there was a moment of collective recognition, a sense that the cosmos had been whispering the answer all along, hidden not in the bright lights of stars, but in the diffuse glow around them. As astrophysicist Alyssa Goodman said, "To understand a galaxy, study its edges, for they remember everything the center has forgotten." Her words resonate deeply when I picture the northern and southern extremes of the halo. One cooler, one hotter, both holding the fingerprints of ancient struggles in the galactic disk. This polarity is not unlike our own emotional landscapes, where some memories cool gently in the background while others burn brightly, no matter how much time passes. As I drift through these thoughts, I begin to see the halo not just as a scientific structure, but as a symbol of continuity. Every star that dies contributes to the halo, and every star that will one day be born draws from it. The halo is the galaxy breathing, inhaling debris, exhaling heat, a cosmic lung cycling the raw materials of existence. And so the lesson it leaves us is simple. Even the faintest parts of the universe hold meaning. Even the thinnest plasma can shape galaxies. What seems empty is often full, and what appears silent is often singing. If you found yourself drifting gently through these images, tell me in the comments what part of this cosmic halo fascinates you most. And as we continue our journey deeper into the vertical realms above and below the solar system, remember this truth that anchors the entire story. The galaxy does not merely shine, it breathes. The first time astronomers traced the faint X-ray glow stretching above and below the Milky Way, they understood they were not looking at quiet space. They were looking at the aftermath of something immense, something ancient, something that had once shaken the very heart of our galaxy. Two vast spheres rising like luminous ghosts, each nearly 14,000 light-years in height, each pulsing with the signature of gas heated to millions of degrees. These are the Erosita and Fermi bubbles, among the largest stars in the visible sky. And to contemplate them is to stand on the shore of a cosmic ocean and feel the echoes of distant thunder still rumbling through the waves. Many scientists describe these bubbles with the calm logic of physics, but even they cannot hide the awe behind their words. Astrophysicist Doug Finkbeiner famously remarked that the Fermi bubbles are among the most astonishing structures we have ever seen in our own galaxy. And the way he said it carried the trembling recognition that the Milky Way has lived through storms far greater than anything humans have imagined. When the Erosita X-ray telescope mapped the sky in 2020, it revealed the full symmetry of these structures, rising like paired lanterns on either side of the galactic plane. Their edges sharp, their interiors glowing, their boundaries carved by shock waves that must once have raced outward faster than anything our world has ever known. Scientists propose two origins for these cosmic balloons, and both are equally dramatic. One possibility is a titanic starburst, an era when the galactic center formed stars in a frenzy, igniting supernova after supernova until the combined energy blasted twin cavities into the halo. Supernovae on their own can carve bubbles hundreds of light-years across. But to create something thousands of times larger, something spanning a significant fraction of the Milky Way's visible height, requires an event of nearly unimaginable scale. As astrophysicist Eric Feigelson once said, "Galaxies breathe through their explosions." And if so, the Erosita and Fermi bubbles are the Milky Way exhaling after a fiery convulsion. The second explanation takes us even deeper into mystery, right into the domain of Sagittarius A*, the supermassive black hole at the center of our galaxy. Today it is quiet, a slumbering beast sipping matter slowly. But evidence suggests that millions of years ago it awoke in a sudden burst of activity, swallowing gas, launching jets, and unleashing a torrent of energy so strong that it inflated the two enormous bubbles we see today. As astrophysicist Jos Bland Hawthorne wrote, "The galactic center has not always been this peaceful." A gentle reminder that even sleeping giants remember how to roar. Historians of the cosmos often compare such outbursts to volcanic eruptions on Earth. Except these eruptions happen not in rock and molten stone, but in fields of plasma 10 million degrees hot. Fields large enough to engulf thousands of worlds. When I imagine these bubbles taking shape, I picture waves of shock battering the surrounding halo. I picture clouds of gas shimmering and cracking under the pressure. I picture the galaxy blinking for a moment, as its silent heart unleashed light powerful enough to glow across tens of thousands of light-years. When scientists modeled the energy required to sculpt these enormous lobes, they found numbers so large they become nearly philosophical. Somewhere between 100,000 supernovae and the accretion of 1,000,000 suns worth of mass must have fed the event. Something huge happened in our galaxy's past, and its fingerprints are still glowing in X-ray and gamma-ray light today. I often reflect on what that means for us. Tiny humans on a pale blue world nested inside a larger bubble, itself drifting within these much older wounds of the galaxy. Carl Sagan once reminded us that we live in a universe of immense beauty and relentless violence. The Rosetta and Fermi bubbles are a testament to both. What fascinates me most is the stillness of the present, set against the ferocity of the past. We look at Sagittarius A times now and see quiet radio murmurs, gentle X-ray flickers, a creature half asleep. Yet the bubbles towering above and below tell us that this calm is not eternal. The galaxy breathes in cycles, wakes and sleeps, erupts and cools, just as stars are born and die. Galaxies themselves have rhythms we only barely understand. Perhaps in another 10 million years, our descendants, if they still exist, will witness another outflow rising from the core. Another pair of cosmic lanterns inflating in the darkness. When I look at the maps of the bubbles, I see not just science, but story. I see the galaxy writing its autobiography in colossal brush strokes, painting chapters in X-ray, plasma, and gamma-ray, winds. Every filament, every boundary, every arc of glowing gas is a sentence in the long history of our home. And the more deeply we read it, the more we realize that cosmic time dwarfs our own narratives beyond recognition. The bubbles began forming long before Homo sapiens appeared, long before Earth's continents settled into their modern shapes, long before our planet even cooled from the turmoil of its own birth. In a sense, we are late arrivals in a story that has been unfolding for billions of years. Some astronomers suggest that these bubbles might still be expanding, but slowly, like smoke rising after an extinguished fire. Their edges ripple with turbulence. Their interiors stir with cosmic rays bouncing through magnetic fields. And their great curved surfaces trap particles that may one day reach our solar system. Not enough to threaten, but enough to remind us that we are connected to the galaxy's beating heart, even from 27,000 light-years away. As I reflect on these ideas, I feel a mixture of humility and wonder. Humility because the galaxy does not rise or fall according to our presence. Its storms erupt without knowing we exist. Its fires burn whether or not anyone watches. And wonder because despite that indifference, we have developed the tools and the imagination to read its scars. We are small, but curiosity enlarges us. We are fragile, but knowledge offers us shelter. In studying these bubbles, we are not merely cataloging celestial structures. We are discovering our place in the grand and restless breathing of the cosmos. If there is a lesson I draw from the Rosetta and Fermi bubbles, it is this. The universe carries its memory not in words but in shapes, in shells, in wounds of light carved across unimaginable distances. To study them is to read the autobiography of time, and in doing so, we learn how brief, how delicate, how precious our own moment truly is. As physicist Kip Thorne once noted, the universe is under no obligation to make sense to us. Yet somehow it does, especially when we look with reverence And so I returned to the bubbles themselves, hanging above and below the Milky Way like ancient lanterns marking the memory of a forgotten cosmic storm. They are reminders that galaxies are alive, that creation and destruction are siblings. That light can linger long after its source has fallen quiet. When I imagine our solar system drifting beneath these faint glowing towers, I cannot help feeling as though we are walking through the ruins of a cathedral built not by hands, but by gravity and fire. And as we continue outward in our thoughts, drifting like Voyager into deeper and darker realms, the bubbles remain behind us, a pair of cosmic footprints left by the galaxy's restless heart. Perhaps that is what makes them so moving to me. They are not merely structures in the sky. They are evidence that even on galactic scales, nothing stays silent forever. Storms rise. Energy bursts forth, then settles back into quiet. Just as in our own lives, the moments of greatest upheaval leave behind shapes that linger long after the storm has passed. The universe remembers through light, and so do we. If you have ever wondered what ancient fires once burned above and below our solar system, leave your thoughts in the comments. Tell me what you believe carved these enormous wounds of radiance. And stay with me as we drift onward, deeper into the galaxy's untold stories, feeling the quiet pulse of the cosmos beneath every word. For more than 70 years, astronomers stared at a glowing arc across the northern sky, a great sweep of radio and X-ray light bending like the curved hull of a forgotten ship. And no one could say with certainty what it truly was. It felt like a riddle carved into the heavens, a relic that refused to speak its name. This structure, the North Polar Spur, hovered above humanity like a half-remembered story, too large to ignore, too mysterious to define. Some believed it was close, frighteningly close. A remnant of a supernova that might have exploded only a few hundred light-years away, brushing Earth with ancient shockwaves long before humans learned to carve symbols into stone. Others argued it must be something far more distant, perhaps a cosmic wall painted upon the galaxy itself, too vast to comprehend, yet woven into our night sky like a silent tapestry. The debate stretched across generations, a quiet tug-of-war between proximity and immensity. The mystery only deepened as better telescopes arrived, each revealing more structure, more texture, yet never deconstructing the enigma itself. As the astrophysicist Bruce Elmer Green once said, "The galaxy hides the truth not by darkness but by excess." And the spur was indeed an excess, a bright wound in the sky that concealed its origin behind layers of light and perspective. For 7 decades, the human story of the North Polar Spur was a story of interpretation, of doubt, of patience. When astronomers looked at it with radio telescopes in the 1960 seconds, they thought they saw the shell of a local explosion. When X-ray satellites examined it in the 1970 seconds, they found something hotter than any old shockwave should have been. When infrared surveys mapped the dust in the region, nothing aligned the way a simple nearby shell would. The spur bent, glowed, and twisted in ways no single theory could satisfy. Still, the allure persisted. A supernova near Earth is the kind of idea that keeps astronomers alert at night. wondering what the cosmos has done to shape the fragile history of life. Space is never quiet, the great astronomer Gene Swank once remarked. It only speaks in wavelengths we learn to hear slowly. And the North Polar Spur spoke in wavelengths no one had yet learned to interpret. Then came the Rosetta telescope, a quiet sentinel, drifting far from Earth, collecting X-ray whispers from the entire sky. When its full map was released, everything changed. The long arc of the North Polar Spur was no longer an isolated shape, no longer a lonely curve in the northern sky. It was revealed as the near edge of something colossal, something that dwarfed not just theories but imagination itself. Two giant bubbles, each extending 14,000 light-years above and below the galactic plane, rose into view. They glowed with shock-heated plasma, X-ray bright, perfect in symmetry. And suddenly, the decades-old debate dissolved like smoke. The North Polar Spur was not a nearby scar but the brilliant rim of the northern Rosetta bubble, a structure so vast it overshadowed the entire Milky Way's central region. The spur was the part of the bubble closest to us, seen edge-on, its curvature magnified by perspective. The revelation struck the scientific world with the force of quiet thunder. All those years, humanity was staring at the echo of a galactic event so powerful that even now, millions of years later, its shockwave still glows across the sky. Some believe it was a burst of star formation, tens of thousands of supernovae going off in fierce succession near the galactic center. Others think the supermassive black hole Sage A times may have awakened for a brief moment, swallowing gas and firing enormous jets of energy up and down through the galaxy. The astrophysicist Karen Sandstrom once wrote, "The galaxy's heart beats slowly, but when it beats hard, the whole halo feels it." And here we are, suspended within that halo, gazing at the remnant heartbeat. What makes the North Polar Spur so emotionally compelling is not just its scale, but the way its story mirrors our own limitations. For 70 years, our instruments were good enough to see the shape, but not good enough to grasp the context. It is like reading a single line of an ancient poem, believing it to be whole, only to discover centuries later that it was one verse in a sweeping epic stretching across the galaxy. We humans, fragile and persistent, often confuse the small piece we can observe for the whole tapestry that truly exists. There is humility in that realization, a kind of cosmic gentleness, reminding us that knowledge and perspective arrive together, hand in hand. And perhaps that is why the North Polar Spur feels almost humanized now, like an ancient traveler who meant no deception, only patience. Its silence was not mischief, only the consequence of our still growing vision. The discovery also carries a strange tenderness. The thought that we live not in a quiet suburb of the galaxy, but in the glowing aftermath of ancient violence. Stars exploded. Black holes breathed. Shockwaves traveled for thousands of light years. And somehow, the Earth survived long enough for oceans to cool and minds to awaken. Astrophysicist Avi Loeb once said, "When you understand how chaotic the universe is, existence becomes an act of cosmic luck." The spur is a reminder of that luck. Yet, As I drift through these thoughts, I find a personal lesson wrapped quietly inside the astrophysics. For decades, scientists believed the spur was one thing, and it turned out to be another. How many times in our own lives do we misinterpret something simply because we see only the part that is nearest to us? How often do we mistake a fragment for a whole, an edge for the structure behind it? The cosmos did not deceive us. We simply needed more clarity, more patience. As the physicist Vera Rubin beautifully said, the universe is under no obligation to make sense to us, not until we learn how to listen. Perhaps the most haunting part of the spur's story is how effortlessly it blends the human and the cosmic. A misplaced arc on a star map became a lifelong puzzle, then a revelation, then a doorway to understanding the galaxy's ancient heartbeat. It teaches us that mysteries endure not because the universe is obscure, but because our instruments of perception are telescopes, our languages. Our expectations grow slowly compared to the immensity of space. And in that slow growth, in that gentle unfolding, lies something deeply beautiful. As we drift beneath the spur, wrapped in the glowing remnants of long-dead stars, it is hard not to feel a sense of reverence. The galaxy is alive with stories, some written in shockwaves, some in starlight, and some in the quiet arcs we misjudge for half a century. We are passengers in a luminous museum, wandering slowly through exhibits built from fire and time. The spur is one such exhibit, a relic of a moment when the Milky Way exhaled a plume of unimaginable energy into the halo. And so, after 70 years of speculation, argument, and debate, the truth glows clearly now. The North Polar Spur is not a nearby ghost, not the faint memory of a star that died in our neighborhood. It is the shimmering edge of a galactic eruption, a luminous wall marking the boundary of a bubble that rises and falls like a pair of silent wings on either side of the Milky Way. It is an edge, yes, but an edge of something so large that our small world floats unnoticed within it. When I think of it now, I feel both humbled and comforted. If the spur teaches us anything, it is that the universe is far grander than our early interpretations, yet patient enough to reveal the truth when we are finally ready to see it. And as we continue drifting through the cosmic dark, perhaps the next mystery already waits above us, quietly glowing. Tell me in the comments, when you look at the night sky knowing this truth, what do you feel rising inside you? Wonder, fear, or the soft realization that even the galaxy keeps secrets until we have learned to ask the right questions? The galaxy has a way of whispering truths we rarely pause long enough to hear. Its light speaks boldly, yet its shadows murmur quieter stories. Among those stories lies one that drifts above and below the Milky Way's shining disk, a tale of two vast magnetic rings circling the galaxy like silent guardian halos. These structures, shaped like colossal donuts of invisible force, hover far beyond the familiar river of stars. And within them we find a puzzle so elegant, so unexpected, that even seasoned astronomers pause in contemplative awe. For in the northern reaches of our galactic halo, the magnetic field flows in one direction. In the southern halo, it flows the opposite way. Two hemispheres, two orientations, one galaxy sharing a divided heartbeat. The cosmos rarely gives us symmetry without secrets. And this opposing dance of magnetism has stirred debates for decades. It is as if the Milky Way itself inhales through one pole and exhales through the other, breathing an ancient rhythm into the darkness. The astrophysicist Brian Gainsler once remarked, "Magnetic fields are the skeleton of the universe, invisible yet holding everything in place. And in these halo rings, that skeleton reveals bones we never expected to find. Their scale dwarfs every notion of human proportion, stretching thousands of light years through space, so thin that a cubic kilometer contains less matter than a breath of Earth's air. Yet what the halo lacks in substance, it compensates with influence. It channels charged particles, redirects cosmic rays, shapes the motion of plasma, and even alters the way we perceive radiation arriving from distant corners of the universe. When cosmic rays born in the embers of supernovae attempt to cross these magnetic rings, they spiral, twist, and ricochet like dancers caught in invisible currents. Some are delayed by thousands of years. Others redirected onto new trajectories. The halo does not merely surround the Milky Way. It sculpts the way energy flows through it. The physicist Vladimir Shcherbakov wrote, "Cosmic rays are the wanderers of the galaxy, and magnetic fields are the roads they cannot help but follow. In the halos above and below us, those roads fork in opposite directions. It is tempting to imagine these halos as static structures, but nothing in the cosmos remains still for long. The fields ripple, bend, respond to the swirling motions of galactic gas and the subtle tidal forces of dark matter. Every supernova that detonates in the galactic disk sends shockwaves upward and downward, feeding new energy into the halo. Meanwhile, the rotation of the entire Milky Way twists the magnetic field lines like taffy pulled across time. What emerges is a dynamic tapestry of force, as alive as the galaxy itself. And yet, why should the northern field point one way and the southern field point the other? There is no simple answer. Some researchers suggest it is the signature of a large-scale galactic dynamo, a cosmic engine in which charged particles moving through rotating gas amplify and organize magnetic fields. Others whisper of ancient asymmetries preserved from the Milky Way's formation, when cold gas streams collapsed into a swirling disk and the halo inherited the memory of that first celestial spin. Michio Kaku once said, "The universe is not only stranger than we imagine, it is stranger than we can imagine." And these opposing halos seem to echo that sentiment like a quiet refrain. As we drift within this vast magnetic cathedral, our little solar system feels the touch of these forces in subtle ways. Cosmic rays that might otherwise strike Earth with greater ferocity find their paths distorted, softened, or delayed. The halo's fields protect us, challenge us, remind us that our world is not isolated, but embedded within an interwoven network of cosmic influences. Even the million-degree plasma filling the halo is shaped by these magnetic rings, guided along lines of force like silk threads drifting in a celestial breeze. Heat, motion, ionization, All feel the whisper of the halo's hand. When I contemplate these structures, I cannot help but feel a kind of reverent humility. The galaxy is older than every dream humanity has ever dared to dream, and its magnetic halos have been flowing above and below us since long before the Earth cooled. They are artifacts of a cosmic past we cannot witness, yet we feel their influence every moment. It reminds me of Carl Sagan's quiet truth. We are a way for the cosmos to know itself. In studying these halos, we are not merely observing distant fields. We are slowly awakening to the invisible architecture that makes our existence possible. But knowledge alone is never the end. It is a lantern we carry, illuminating both the world around us and the world within. And so I find myself reflecting on what these opposing halos might symbolize on a more human level. Perhaps they teach us that duality is not a flaw, but a feature of existence. North and south, expansion and contraction, ascent and descent. The universe grows by embracing opposites, and in that rhythm, we too must learn to flow between tensions without losing our center. There is something profoundly meditative in imagining the galaxy wrapped in two great magnetic rings running counter to each other. It feels like the inhale and exhale of a cosmic breath, a pulse that syncs with the slow drifting of stars and the gentle wandering of planets. When I picture our solar system moving through this magnetic environment, I imagine a small boat gliding across an unseen ocean, carried not only by gravity but by forces too delicate to feel yet too powerful to ignore. The more we learn, the more the halo seems less like a boundary and more like a cradle, a surrounding field that both shapes and shelters the dynamic story of our galaxy. High-energy particles that might erode atmospheres or disrupt biological evolution are softened by this magnetic gauze. And though cosmic rays still reach us, their journey is shaped by the halo's intersecting curves, making our planet a little more hospitable, a little safer. I often wonder how many galaxies across the universe harbor similar halos, bent and woven by colossal magnetic currents. And how many of those halos whisper to their resident civilizations, guiding their evolution quietly, invisibly. The astrophysicist Rainer Beck said, "Magnetic fields are the dark energy of galaxies, unseen yet essential." His words echo deeply here, for these halo rings are essential threads in the Milky Way's hidden anatomy. In their presence, I am reminded that the cosmos does not merely exist. It composes, improvises, creates. And we are fortunate enough to be listeners, drifting within earshot of this silent symphony. My personal takeaway from studying these magnetic structures is simple yet profound. The more invisible a force is, the more crucial it often becomes. Gravity, dark matter, magnetism, even the fragile hope that binds human beings together. All of it unseen, all of it essential. If you find yourself stirred by this cosmic imagery, I invite you to share your thoughts in the comments. Do these opposing halos make you feel small, protected, or perhaps curiously connected to something vast and unspoken? Tell me what you imagine when you picture the galaxy's magnetic breath flowing above and below us. And as we drift onward through this cosmic meditation, carried gently by the Milky Way's invisible tides. Let this truth settle softly within you. We are not merely residents of a galaxy. We are participants in its ongoing creation. The halo rings above and below us are more than magnetic fields. They are reminders that the universe is alive with structure, intention, and astonishing grace. And in understanding them, we move one breath closer to understanding ourselves. Out in the quiet halo of the Milky Way, far above and far below the shining river of its spiral arms, there drift the ancient globular clusters. They move like lanterns of a forgotten age. They shimmer like fossilized memories suspended in the dark, where time itself seems to hold its breath. And when I look at them through the lens of a scientist who has spent a lifetime listening to the whispers of the cosmos, I sense something deeper than data. These clusters are old, impossibly old. 10 to 12 billion years by our best measurements. They were already ancient when Earth was still smoke and magma. They were glowing when the galaxies were young and the universe had only just begun to cool enough for atoms to cling to each other. And each cluster, a tight sphere of hundreds of thousands of stars, moves with a dignity that feels almost human in its persistence. Some of them circle the galaxy backward, contrary to the grand rotation of the Milky Way's stellar disk, as if refusing to follow the rules, as if carrying the flag of some ancient movement long dissolved into stardust. Astrophysicist Katherine Johnson once said, "Old stars carry the memory of the universe, even when the universe forgets itself." Her words echo for me whenever I study these clusters, for the globular clusters are the memory of the Milky Way. They witnessed its birth, its collisions, its cannibalism. They are silent historians drifting through the halo, watching over a galaxy that rarely looks back at them. Yet what moves me most is not only their age but their scars. Their orbits are twisted, stretched, reshaped by billions of years of gravitational struggle. Some clusters we see today were not even born in the Milky Way. They were once the hearts of small galaxies, devoured by our own. Cosmic archaeologist Hans Walter Rix wrote, "The halo is the graveyard of galaxies, and their bones shine." When I read that, I felt a chill. For those bones are glowing globular clusters, carried like relics from galaxies long vanished. And trailing behind some of those ancient companions are the stellar streams, long, narrow, river-like currents of stars pulled apart by the tidal forces of the Milky Way. To look at a stellar stream is to watch a galaxy eat another galaxy in slow motion. The most famous of these is the Sagittarius stream, a majestic ribbon of stars that loops around the Milky Way like a shimmering scarf. Its parent, the Sagittarius dwarf galaxy, is currently being torn apart, stretched into filaments, unwound by the immense tide of our galactic center. This process is not violent in the sense of an explosion, but it is relentless. Gravity is patient, and patience is a force beyond imagining. Astrophysicist Carlo Rovelli said, "The universe is not violent, only indifferent." And the stellar streams are evidence of that indifference, beautiful, delicate, poetic, but born from a quiet cruelty that slowly unravels entire galaxies. What fascinates me is how these streams stretch across hundreds of thousands of light years. A single thread of stars, each following a gravitational remembrance. Some stars in the streams were once neighbors, separated by only a few light days. Now they may be thousands of light years apart. Imagine a village blown into the wind, houses drifting apart, leaving only a faint outline in the sky where a community once lived. That is what a tidal stream is. And yet, there is beauty in this cosmic erosion. The streams outline the very shape of the Milky Way's gravitational field. They reveal the invisible distribution of dark matter. They act like starlit fingerprints left behind by ancient collisions. Princeton astronomer Jim Peebles once remarked, "If you want to see the dark matter, watch how the stars dance." These streams are that dance, a slow, spiraling choreography across the night spanning eons beyond imagination. What moves me deeply is how they connect cosmic violence with cosmic art. Every stream is technically a wound, the torn artery of a small galaxy, bleeding its stars into the Milky Way. But in the sky, those wounds glow like silver threads. Proof that even destruction can be breathtaking when stretched across deep time. When I reflect on the globular clusters and the stellar streams together, I see the full arc of the galaxy's biography. The clusters are its childhood memories. The streams are its battlefield scars. Together they whisper the truth that our galaxy was not built peacefully, but through struggle, merging, devouring. Galactic evolution is not gentle, but it is beautiful. And in the quiet moments of the night, when I speak into a microphone hoping to help someone fall asleep to the sound of the universe, I often think about how every human life mirrors these cosmic processes. We too carry ancient memories, though ours are stored not in orbits but in stories. We too feel tidal forces, the pressures of time, gravity of relationships, the pull of our pasts. We too break apart, only to form new streams that may guide someone else someday. My personal reflection is this: when I study globular clusters, I see proof that age does not diminish radiance. These clusters are old, older than the light in most stars we know. And yet they shine with a calm, concentrated brilliance. The lesson they whisper is simple, that endurance is a form of beauty. From the stellar streams I learn something different. They teach me that loss, even cosmic loss, can create new shapes. The galaxies torn apart billions of years ago did not vanish into darkness. They left glowing trails that help us understand the Milky Way itself. Out of destruction came knowledge. Out of fragmentation came meaning. And perhaps that is the quiet wisdom of the galaxy. That what breaks in us can still become a map for someone else. That what we lose does not always disappear. Sometimes it becomes a luminous thread guiding future travelers. When I think of the halo of the Milky Way now, I no longer picture emptiness. I see an ocean of memories, swirling, shimmering. I see the ancient clusters, proud, resilient. I see the long stellar streams, delicate as smoke. I see a living history book written not in ink but in motion. Astrophysicist Gaia Weaver put it beautifully. Above and below the galaxy's bright disk lie the truths it hides from itself. And those truths drift around us even now. As you listen to this, perhaps lying in bed, your breathing slowing to the rhythm of the universe, I invite you to imagine yourself floating in the halo, watching these streams and clusters drift by. Imagine that you are as ancient as those stars, as patient, as luminous. Because in a sense, you are. Every atom in your body was once part of stars older than the galaxy itself. You are made of the same materials as these clusters, shaped by the same forces. The universe is not just around you, it is within you. And perhaps that is the most comforting thought of all, that in this vast and sometimes lonely cosmos, you are not a stranger. You are family. A child of stellar memories. A descendant of ancient streams. Drifting. Glowing. Becoming. The first time I stared into the deep maps of the Milky Way, I felt as though the galaxy itself was tilting beneath me. Because above the quiet shimmer of the stellar disk, beyond the familiar spiral arms we have memorized like a childhood lullaby, there lies a structure so improbable that even seasoned astronomers pause before speaking of it. A thin plane of satellite galaxies, only 30,000 light-years thick, circling the Milky Way in a single united motion, as if obeying some forgotten choreography written long before our sun was born. Most galaxies scatter their satellites like seeds in a storm, flung in all directions, uncaring and unpatterned. But our galaxy is different. Half of its satellites cling to this narrow plane, all drifting the same way. It is a structure that should not exist. And yet, there it is. A cosmic whisper of an ancient alignment. The astrophysicist Konstantin Batygin once said, "The universe is never lazy. If a pattern exists, it exists for a reason." Those words linger in my mind as I imagine that delicate plane extending like a thin silver blade slicing through galactic darkness. Because for this pattern to survive billions of years, something colossal must have shaped it. And it did. The dark matter halo, our galaxy's invisible skeleton, appears to be tilted, twisted away from the luminous disk we can see. A hidden mass, a silent ocean of unseen particles, leaning into one direction like a great shadowed wave preserved in eternity. This tilt is not gentle. It is not subtle. It is a sign of violence, of ancient collisions, of mergers so profound they left the galaxy itself permanently skewed. Galaxies wear their scars in their halos, astrophysicist Sarah Tuttle reminds us. If so, our Milky Way carries a wound still visible across 100,000 light-years. I imagine the moment billions of years ago when a smaller galaxy crashed into ours, its dark matter core plunging through the Milky Way like a ghostly spear. Stars trembled, orbits twisted, the halo shuddered and turned. And the satellites we see today, arranged in their surprising plane, may be nothing less than survivors of that ancient cataclysm. When I consider that, I can almost hear the galaxy breathing. A long, slow exhale across epochs we cannot count. For the tilt of the halo is not just a geometric curiosity. It is a record of memory. A celestial diary written not in words but in gravitational bruises. And this tilted darkness does more than shape the orbits of entire galaxies. It reaches down to the smallest icy bodies at the farthest edge of our solar system. The Oort cloud, that distant sphere of comets drifting tens of thousands of astronomical units away, is tugged and stretched by this misaligned halo. Some comets feel more pull from the tilted darkness than from the sun itself. They fall inward, slipping into long ellipses, crossing the paths of the planets. Perhaps the comet that ended the age of dinosaurs rode such a gravitational ripple. Perhaps many of Earth's turning points were pushed into being by a halo we cannot see. The halo tilt also touches the globular clusters. Those ancient spheres of stars older than our sun, older than our galaxy's spiral arms, older than most of what we call the Milky Way itself, move like migrating lanterns around our galactic home. Some orbit backward. Others loop in arcs that defy the disk's rotation. Their strange paths, long misunderstood, begin to make sense only when we admit the truth of the tilted halo. It is like watching birds move across a sky where the wind itself is crooked. Invisible yet undeniable. As I drift deeper into this thought, I feel the scale of this revelation unfolding slowly like a nebula blooming in silence. The Milky Way is not the orderly pinwheel of textbook diagrams. It is a layered organism, part luminous, part invisible, part wounded. A living archive of collisions, migrations, annihilations. And in its tilted halo lies the story of its survival. The cosmologist James Bullock once observed, "Dark matter is the stage on which galaxies perform their dance." If that is true, then our galaxy is dancing on a tilted stage. Every star, every comet, every drifting cluster moves in choreography shaped by an unseen incline. We are the children of asymmetry, born into a cosmic house built slightly askew. I sometimes wonder what this means for us personally. Humans crave symmetry, order, predictable patterns. Yet the galaxy we belong to tells a different story. A story where beauty is forged in imbalance, where meaning emerges from collision, where even a tilted skeleton of darkness can shepherd whole families of galaxies into one elegant plane. As I breathe with the quiet rhythm of these thoughts, something gentle settles in me. The world we navigate daily feels chaotic, unpredictable, filled with events we cannot control. But the galaxy reminds us that chaos can still produce pattern, and violence can still leave harmony in its wake. The satellites orbit together because the halo tilted. The clusters survived because of the very forces that tried to scatter them. Even the comets arriving from the darkness carry messages from a geometry shaped by ancient upheaval. What lesson could be clearer for us sitting here on this fragile blue planet? Perhaps it is this: that our paths, like the orbits of those distant satellites, are bent by forces we cannot always see. Yet even a tilted foundation can guide us into unexpected alignment. And sometimes, The universe leans just enough to allow us to become who we were meant to be. As I let these reflections drift outward, dissolving into the soft, dark of interstellar space, I feel a tenderness toward this imperfect galaxy that raised us. A galaxy with a crooked spine, a slanted heart, and a history stitched together from collisions and quiet recoveries. We exist because the galaxy is not perfect, but because it is beautifully unbalanced. And perhaps that is enough to make us lift our eyes to the sky with new wonder. If this thought settles gently within you, share it in the comments. Tell me how you imagine the tilted darkness shaping our future. And together, we will continue drifting through the strange sweetness of the cosmic story unfolding around us.